Have you ever thought about what the future rackets would be like? How do you imagine it? Bigger, lighter, more resistant?
All of this can be achieved with specialized Industry 4.0 software, such as Altair.
We are three students of the Industrial Design Engineering at the University of Elisava, Clàudia, Alícia and Joaquim, and we will present you ACE.
ACE aims to be lighter,
More resistant.
and more aerodynamic.
To do this, we rely on the following hypotheses. First of all, the material. We have investigated how tennis rackets are manufactured, and we have observed that the main material is carbon fiber. So for our study, we have extracted properties of its material from Grado database, since both its fiber and its matrix are made of carbon. Next, we have the constraints. For the simulation of the racket's efforts, we fixed its structure by the handle, blocking everything on the X, Y, and Z axis. To hypothesize the forces on the racket, we have used a critical case, where the ball impacts at 70 meters per second on the sweet spot, which is located here, and which is the point of minimum vibrations. The impact force of the ball is transmitted through the strings and distributed through the holes of the structure, creating a momentum. On the other hand, the strings of the racket must be tensioned, in this case static, to 24 kilograms. Therefore, generate the pressure on the outer surface of the racket towards the inside.
Now that we have explained all the hypotheses, let's get into the simulation. Let me show you. If we pass this to the inspired program, it would look like this. For the simulation, we first looked for a 3D model of a racket and separated its structure into three parts: the arc, the triangle, and the handle of the racket, in order to optimize its elements independently. In the case of the triangle, it was made in a topological way, where we did multiple iterations from which we modified several parameters, until we were left with two definitive models, the first and the last ones, since they were the ones that gave us the best results and were the most viable in terms of structure. Here, in the first model, this part was defined as design space. Also, 3mm partitions were made to keep the string holes in the structure, as you can see. All of that was done without touching the thickness of the whole racket, which means that it was not a solid object, as you can see as well. This was optimized by maximizing the resistance and maintaining a mass target of 30%. In terms of the results, we obtained that the weight has been reduced from 0.165 kilograms to 0.135 kilograms, achieving the same resistance and with a slightly different design. In the second model, unlike the previous one, the entire racket was solid, and instead of splitting the arc in this part, it was left entirely, and the triangle was adapted to cover the lower part of the arc, as you can see here. In terms of optimization, it was done in the same way as the first model, maximizing the resistance and maintaining a mass target of 30%. In this case, it has also been possible to see how the weight has been reduced from 1.026 kilograms to 0.875 kilograms, which is quite considerable, even though both weights have been increased since the racket is not empty inside. So combining the skills of Creo software and Inspire, we imported both models, and from its freestyle modeling function, we designed a combination of the best aspects of both, leaving a result like this. Once we got the triangle, we moved on to the handle, which was made with a lattice. Structurally, we left the entire arc with the original thickness, and the other parts were left solid. In addition, in this section we added two bases at the top and at the bottom of the handle, to be able to apply these constraints without being inside the design space, and also so that the lattice had a better connection with the other parts of the racket, and a better resistance. Thus, the optimization was carried out, maximizing the resistance with the following lattice parameters and with a mass target of 30%. Finally, the results obtained were very positive, having a high safety factor over 6 and not having either a large displacement or large stresses, even though we had a case study with forces taken to the extreme.
Finally, it's worth mentioning that optimizing this racket using Inspire software has helped us a lot to reduce weight and gain strength on the final product. From this program, we have been able to work in an innovative and efficient way. Inspire software has been a key point for the development of this work and our professional career. It has been very useful, practical and decisive when working to obtain better results to move forward and create really innovative and fruitful products in the working world.